Hello everyone, welcome to LRDIprep. My name is Samir Sardana. So we are discussing this last 5 years of CAT paper series, and this is episode 3 of Slot-2, and we are discussing questions, tricks to solve every question under 1 minute. Subscribe to this channel to get your 100% syllabus coverage. This is my referral code for the plus subscription. Have a look at the next question from Maxima Minima, question number 7 of CAT 2020 question paper Slot-2. For real x, the maximum possible value of this expression is what? I want to find out the maximum possible value of this. You can easily solve this question within 10 seconds. The trick to solve the question in 10 seconds is just observe the expression. If I want to maximize the value, I will be looking for a least possible value in the numerator, right? If I want to maximize this whole value, I want least possible value in the denominator. And we know that this is definitely going to be a positive integer. I cannot put x as 0 because then whole expression will be equal to 0. I want to maximize it, not minimize it. So the least positive value in the denominator that you can have would be at x equal to 1. So you will have the least possible value in the denominator when you put x as 1. Now if I put x as 1, the expression will be equal to 1 by root 2, which is the max possible value, and that's it. This is the answer of the question, which is option number 2. It will take only 10 seconds to answer this in the exam if you have this basic common sense to interpret the questions of algebra. This is one method. Let me also tell you the alternate method, right? You can also solve this question with AM-GM rule. What you can do is, you can write down this expression x upon root 1 plus x power 4. X upon root 1 plus x power 4. This is method number 2, right? The method number 1 is very simple, which I have already discussed. What you can do is, you can take x in the denominator. So can I write down this expression as 1 plus x power 4 divided by x? Then you can also write it down as 1 upon root upon, you can take x inside the square root. So this would be x square plus x square. When you take x inside the square root, you will be writing it down as x square. Now to maximize it, I need to minimize this value. Now 1 upon x square plus x square, the arithmetic mean of this expression will be greater than or equal to geometric mean of this expression, right? And you see that geometric mean is 1. So can I say x square plus 1 upon x square is definitely greater than or equal to 2. So the minimum possible value of this expression, which is inside the square root, is 2. So therefore the maximum will be obtained when you putting this expression as minimum possible. So the maximum is 1 by root 2. That's a alternate way of solving the question, the second method. But you see the first method is more effective and will give you the answer in 10 seconds. Let's look at the question number 8 of linear and quadratic equation. It says the number of integers that satisfy the equality. So we have this expression, right? Similar to this question. Exactly a similar type of question was asked in the morning slot 1, morning slot 2, and also in morning slot 3. See that from exponent chapter, you should be knowing that if I want an expression with the index to be equal to 1, there will be 3 cases. Case 1 will be a power 0 should be equal to 1. Case 1 would be 1 raised to power any power will be equal to 1, and the third case would be minus 1 raised to power an even number will be equal to 1. So I'll be taking 3 cases. 1 will be the case when this value in the power is equal to 0. That means x is equal to minus 1. At x equal to minus 1, this becomes 0. Now whatever this become at x equal to minus 1, value will definitely be equal to 1. Now you just need to see that at x equal to minus 1, it should not be 0. When I put x as minus 1, this is 1 plus 5 plus 7. It is 13. So 13 power 0 will be 1. So the first value, right, the first integer that satisfies this is x equal to minus 1. Second, all those values where the value in this bracket, that means all those values of x for which this quadratic equation becomes equal to 1, the expression will be equal to 1. So that means I want all those values of x for which x square minus 5x plus 7 is equal to 1. So this is x square minus 5x plus 6 is equal to 0. On factorizing it, you will get x as 3 and 2, right? Now at x equal to 3, this quadratic will become 0. At x equal to 2, this quadratic will become 0. Sorry, at x equal to 3, this quadratic equation will become 1, and at x equal to 2 this quadratic equation will become 1. Now 1 raised to power anything is always equal to 1, so these are the two more values of x that will satisfy it. Let's look at those values where the value in the quadratic equation is equal to -1 and the power should be even. So when I make it x square minus 5x plus 7 is equal to -1, I'll have the equation as x square minus 5x plus 8 is equal to 0. Now x square minus 5x plus 8 is equal to 0. Now you see that if I look at the roots of this, discriminant of this quadratic equation is b square, that is 25 minus 4 into a into c, which is less than 0. Now if discriminant is less than 0, that means there is no real value of x at which this expression can become equal to 0, or you can say there is no value of x at which this becomes equal to -1. There is no real values of x at which this becomes equal to -1. So I'll not get any solution from this part. So 2 solution from here and 1 solution from here. Answer is 3 solution, right? Is it clear? Right. Let's look at the question number 9. The number of pairs of integer xy that satisfy this given expression. Now, this is a question from how to find out the integral solution of linear equations. Now, x is greater than equal to y is greater than equal to -20, and 2x plus 5y is equal to 99. I'm supposed to find out the pairs of xy which satisfying this equation with the condition that x should be greater than equal to y and y should be greater than equal to -20. Now look at this line. What is the slope of the line? Slope of the line is change in y upon change in x. Change in y is basically the coefficient of x, and change in x is a coefficient of y. And because it's a decreasing line. Why it's a decreasing line? Because this value is fixed. If I increase x, I'll have to decrease y. It's a decreasing line, right? Any line of the form of ax plus by is equal to c is called as a decreasing line, right? So change in y upon change in x will be equal to 2 upon 5, and because it's a decreasing line, so slope will be negative. So that means when the coefficient of y get changed by 2, if I'm decreasing the coefficient of y by 2, I'll be increasing the coefficient of x by 5. If I'm decreasing the coefficient of x by 2, I'll be increasing the coefficient of x coefficient is getting decreasing by 5, y coefficient will get increased by 2. These are the standard rules of equations, right, that you should know, of linear equations, right? Any basic standard book will have these rules, right, if you have studied the basic linear equations. Now look at the first solution that you want. Because I want x to be greater than equal to y, so I'll try to minimize the y. If I put y as 1, you see that if I put y as 1, the value of x that I will be getting, would be equal to 47. And you see that here x is greater than equal to y, both are greater than equal to -20 also. The first possible solution, as I can see here now, is that when you're putting the value of x as 47 and y as 1, the next possible solution will be obtained by decreasing the x by 5 and increasing the y by 2, that is 3. The next solution, again decreasing it by 5, 37, increasing it by 2, again increasing it by 5, decreasing it by 5, 32, this will be 7, then this will be 27, this will be 9, this will be 25, this would be 11, right? Sorry, this is 32, 27, this would be 22, then this will be 17, this will be 13. If I decrease it further to 12, this will be 15. Here x is less than y. This will not be a valid solution. I'm looking for x to be greater than equal to y. So how many solutions I got? 1, 2, 3, 4, 5, 6 and 7. You can also get a solution when you are decreasing x, when you are increasing x and decreasing y, because y can be decreased till 20. And we know that the next possible solution would be -1 and this would be 52, because I'm getting this solution by decreasing y by 2 and increasing x by 5. That means I'm going on the negative side of y, right? But then you see that now I don't need to check whether x will be greater than equal to y or not, because y is negative and x is positive. X is moving towards positive and y is moving towards negative. So x will always be greater than equal to y. I just need to see from -1 -3, -5 till -90. If I want y to be greater than or equal to -20, the last solution will be -19. So 1 to 19 with a gap of 2, I'll have 10 solution, right? So 10 solution here, 7 solution here, answer is 17 solution. The number of pairs of integers of x5 that satisfy the equation will be 17. That's the correct answer of the question. Guys, this is my referral code for Plus subscription. This is my Telegram group given the description part of the video, and this is the YouTube channel that you need to subscribe to cover your syllabus. And you can attend a session on 30 minutes daily DILR with me at 4 p.m. I'm going to cover 300 best set of logical reasoning and data interpretation before CAT in this series. 39 episodes have been conducted till now. Links of all those episodes are given in the description part of this video. Have a look at it. You can cover one episode on daily basis, and live you can also watch the sessions at 4 p.m. Cover your syllabus 100% at LRDIprep. And guys, these are my courses in the next 90 days to cover the whole syllabus of CAT. These are the courses I'll be taking on live on Unacademy Plus. This is my referral code for Plus subscription. The weekly scholarship test happening on the upcoming Sunday at 12 p.m. You can use my referral code LRDI Live to unlock the test. Also, Ask a Doubt option is live on Unacademy Learning app, where you can get the video solution of the doubt by just uploading the picture of the doubt that you have, and you'll get the video solution as soon as possible. Thank you so much for watching the video. See you in the next part. Thank you.